Hello, everybody. So this is a problem right here that I know you're supposed to solve using heaps, but I do not know how to use heaps yet. Uh, so I solved it another way. You can use lambda functions. Lambda functions are super useful, and I want to show you guys how I solved this problem. So we have a list of points on the plane. Find the k closest points to the origin, 0, 0. Here, the distance between 2 points on a plane is the Euclidean distance, I guess. You may return the answer in any order. The answer is guaranteed to be unique, except for the order that it is in. So here we have points. We're given 2 points, 1, 3, negative 2, 2. We realize that points are given to us in an array of arrays. And then here we're only supposed to return 1 point, which is k, the k closest point. So the closest point is basically returning. The closest point is negative 2, 2. You can think of this as x and y. So you say the distance between 1 and 3, the distance between 1 and 3 and the origin is square root of 10. The distance between negative 2, 2 and the origin is 8. Since square root of 8 is less than square root of 10, negative 2, 2 is closer to the origin. We only want the closest k equals 1 points from the origin, so the answer is just negative 2, 2. And then here they gave us several points, and we're supposed to return the k 2 closest points, so 2 closest points to the origin, and that's these 2 points right here, and that is the answer. So they don't care about the order really, they're just saying give us the closest points. All right. Very, very interesting. So I took a photo here and I have the distance formula. You probably remember this from like middle school or probably elementary school, I don't know. So the distance is x2 minus x1 plus y2 minus y1, both of those squared in the square root. Now we go over here and we think to ourselves, how did they do the math, right? So let's grab this and see if we can post it here. For some reason, okay, I can't click because I'm on this thing. Place image. Very cool. So they got the distance between 1, 3 and the origin is square root of 10. So we know immediately, right, that we're working with 0, 0. Why? Because the origin is 0, 0. So we can kind of think to ourselves like, okay, we're doing x2 minus 0, y2 minus 0 squared. What does that actually look like? Well, that actually looks like the value for x that we're given, like let's see here 1 plus, and you square that, plus the value of y squared, which is 9, and then you're supposed to do 1 plus 9 square root of so we're going to be having like 1 minus 0. So let me just draw this out. So here we have the square root sign. I've never been good at drawing straight lines. So here we have 1 minus 0, 0. All right. Squared minus, then here with y2, which is 3, minus 0 squared. And you could honestly treat either y1 or like y2 and y1, they're interchangeable, right? Because if we have like 0 minus negative 1, what's negative 1 squared? Negative 1 squared is 1. Then we have, this is a plus right here. And then we have 0 minus 3 is negative 3. Negative 3 squared is 9, right? So it doesn't matter the order you put the numbers. So you just plug in the numbers anywhere you want, as long as x2 is matching with y2, like in relation to their position, like which one's like subtracting from which one. So then this right here gives us a square. This right here gives us a square root of 10, right? And we don't really have to take the square root, right? Because now let's look at this other number. which is, let me see if I can somehow make this a straight line. Oh wow, we're upgrading here. That's what I'm telling you guys right now. We're upgrading right now to with this new technology of being able to make lines. They still suck because I'm not an artist, guys. So yeah. So here, let me see. So I'm going to draw again using the pencil. Then here, what do we have? We have -2. So that's our x1, right? Minus 0 because we're at the origin. 0, 0 plus, and then it's squared, right? Plus, then we have y2 minus y1, right? So y2 is 2 minus 0. And then if we square that, what is this? What's -2 minus 2? -2 minus 2 is, well, it's not minus 2, it's 0. -2 minus 0 is 0. -2 squared is 4, right? And then we have 4 plus, wait. So yeah, this is 4, and then this is 4 and 4. This is 8, right? So that's square root of 8. Why? Because here we have 4 plus 4 is equal to 8. Yeah, I'm not going to explain how the negatives work or anything, but because that's like some, I don't know, math that like, yeah. So this is equal to this. This is equal to this. All right. So the output should be -2, 2, right? So here we have 10. So this we're supposed to take the lesser one, right? So we know that the square root of 8 is less than the square root of 10, right? So this is the one we want to return, right? So we want to return the coordinates associated with square root of 8, because we're only going for the k equals 1, right? The one that's the closest. If it was k equals 2, we would include all of them, right? All right, so I think to myself, all right, very cool. And if you notice, you don't actually have to take the square root because, and they don't take the square root in the problem. But you already know, right? If you have a square root of 1,000,000 and square root of 10, which one's going to be greater? Square root of 1,000,000, right? Because it's like you're taking two numbers, applying the same exact thing on them. You take two numbers and apply the same exact thing on them, then like they're basically going to be in the same relative position to which they were beforehand, if that makes sense. So let's check this out now. What am I going to write? That's a good question. So I'm going to say for point, actually I'm going to just say for I in range, or just say for index in range, the length of points. So what I want to do is I want to like go to each point and find out its distance, right? So we're going to say distance equals distance self dot distance, and you could have to do self on stuff because it's part of a class. Normally, if you're doing regular code, you don't, like in your using like an ID, don't put self, right? So yeah, then we have distance of what we have, the distance of points, our list at that particular index. We're going to send that there. So we're going to send the points, that those 2 points, right? Because it comes in a pair. But we're sending this array right here to our distance formula, right? So we're going to say define distance self comma points, right? So what do we want to do, right? We want to do points. We want to return something to this, right? Because we're making this equal. So what's the distance at that particular point, right? Return points. I'll call this point return point of 0, right? The thing at the first index for this array. Square it plus point of 1, and then square that, right? So now let's check this out. I'm going to say like print distance, right? So now we have 10 and we have 8, just like how we wanted, right? And we know that 8 is less than 10. So we're like, okay, cool. Now let's just like return the one that's associated with 8. But wait a second. We don't actually have a way of associating 10 or 8 with their respective values, right? So then like, how are we going to tell the computer, oh, like the number 8 is associated with this point, -2, 2, or the number 10 is associated with 1, 3? Well, what we can do is we can just add those numbers, add those distances to our array, right? So what we're going to say is we're going to say like points, right, at that index, like at index 0, we are going to want to append a distance, right? So now we can like print out our points, and now let's see how it ends up. Okay, cool. Now we have like these points here, but then like, how are we even supposed to like, okay, now we have like 10, and 10 is in there, and 8 is in there as well. So we have like the points like associated, but then like, how are we supposed to like our return? We're supposed to first find out like, how are we even supposed to like put this in a way so that way we can like, there's several things we need to do, right? First, we need to like put 1, 3, 10, and -2, 2, 8. We need to put it in a way where we can like see, like, what if this was like a list of like a million things? Like, how would we get the thing with the lowest third number, right? So that is where lambda functions come in handy, and we can sort this using a lambda function, right? So we can say sorted dist is equal to sorted, and what are we going to take in? We're going to take in our points array, right? And then we're going to use our lambda. I think I have a thing open right here. I'm going to look at it. Okay, so it's key. So this is like how lambda functions work. I haven't used them that often, but they're pretty often in some scenarios, right? And sometimes in interviews they let you like look at stuff, like look stuff up. But hopefully, you know, you remember this, but haven't remembered it yet. So whatever. I'm just gonna copy and paste this and then change it to work for my code. So I've sorted points, which is our list, and then our key, which is how we're sorting it, right? Lambda, which basically means like an anonymous function that just works right here. We're going to take in, we have in our list, right? We have like a list of like things, right? So we want to say like, okay, if we go into our list, right, and we go into like the first thing, right? We don't want to sort with respect to like this first thing. We want to sort with respect to the third thing inside of this thing, right? So pretend X is this tiny array here of 1, 3, 10. We want to sort with respect to the thing that is third within this array, or actually it's 2, right? Because we're working with indices here, because we're 0, 1, 2, 0, 1, and 2. All right, now let's see how this turns out. We're going to print sorted dist. Cool. So now it is sorted. Before the order was flipped, right? We had 1, 3, 10, and then -2, 2, 8. Now it's sorted with respect to the thing at the third and at the second index for each array, right? So now we need to return. We only want the k closest points, right? So we have to like do like we have to make a new array for us to return stuff with, right? Because we have to like put it in the format that they want us to return it in, right? We can't return like this. So, and we also need to return multiple things. We're gonna say for, let's say like I in range k. So how would we do this? So I'm looking at this right now, and we only want the k 1 point, or the second the k equals 2. So then how would I make this work, right? So immediately I know that for example, the first thing, because I sorted it, is the closest thing, right? So for I in range, I need to make another array, right? So I need to say closest list, or let's just call it closest, and make it an empty array. And I have to say closest dot append so the list is sorted dist, right? I want to return 0 because we don't want to return the distance. We just want to return the points 0, 1. So now let's print out closest and see how that ends up. Append takes exactly one argument, 2 given. We need to put this in an array as well, right? Because it's an array of arrays. And now this is one argument, right? So closest dot append sorted dist of 0 and sorted dist of 1. So if I print a sorted dist, I get, okay, I see now. I mean, it has too many arrays, right? So I need to do this sorted of I, right? So it's just saying that for the first thing, for whichever k point we're on, for whatever I point we're on, right? So let's say like here we're iterating k equals 1 time. So for I in, so we're only doing it once. So I is going to be 0. So 0, 0, we're going to go to the first thing within our array of arrays, and then go into an individual array, and then get out the first point, which is our x, and then we're going to get out the second point, which is our y. And now if we print that, it should, I think we have to do it like this. Yeah, that's perfect now. So now, because it only takes, append only takes one thing in, we need to put this right here as an array, right, of 2 points. So now we say print closest. This is our answer now, so we can just return it. Return closest. Run and submit, and it worked with good runtime and good memory usage as well. And we just like submit again, because it changes, yeah, it's within that range, which is pretty decent. So you're supposed to solve this problem using heaps usually, but this is a different way. I think it's really important to know how to use lambdas because they're really useful in different scenarios where you have to be able to just like make an anonymous function that can do something pretty useful for you. And I think that they're like kind of like a secret weapon that a lot of people don't know about. I did make some mistakes along the way. Like I didn't know like append could only work with like one thing or something like that. And I had it like an array, but it's fine. We just adjusted our code accordingly. Our logic was solid, and yeah, if your logic is solid, the code will follow. So that's it. And yeah, so just want to say thank you for watching. Please like, comment, and subscribe about how much you love algorithms.